So the way to get Python to let us generate the so-called random numbers is to import a library called random. So up at the top of our code, we're just going to add an import statement so that we can do that. Now a little bit of lecture about random numbers is they are not really random, right? Not nearly as random as actually rolling the dice. And the reason why is everything in a computer has to follow like a set sequence of stuff. The computer doesn't have a die inside it that it can roll, right? So instead what it does is it bases the next number that is rolled on the last number that was rolled. And so it just keeps using this formula to generate the random number. Now Python's is pretty good. Its random number generator is pretty good, but if you set a so-called seed, it'll always generate the same sequence every time. That's not random at all. Well, how do programs like Python, how do languages fix that? They'll pick that seed, that starting point, like based on the number of seconds since midnight. So that unless two people are starting the program at exactly the same time and down to the second or down to the millisecond, the sequence of numbers will be different. So we might play with that first before we actually write the thing where we roll two dice. Let's go ahead and go into idle. Looks like we're on Lecture J. What are we going to be talking about? We're going to be talking about random numbers, and we're going to be talking about modules, which in Python are called functions. I'll use the terms interchangeably. The book calls them modules. All right, let's play with the random numbers. Now I'm going to Google up the exact command that is used to generate the random number just because I don't want to get it wrong and I have to Google it in a minute. So random Python integer range. It says generate pseudo-random. That means that it's based on a mathematical formula. So it starts with a seed, whether you give the seed or the seed is determined by the number of milliseconds since midnight or whatever. And let's see the actual function name that returns a random number. Well, it's just random parentheses, but I don't want. If you just call random parentheses in parentheses, it generates a number between 0 and 1 with a lot of decimal places. I don't really want that. Instead, I want a random integer like that. And so we're going to use a function called randint. So import random, and then just do print parentheses random dot randint parentheses in parentheses. So it's a module call, it's a function call. Whenever anything ends in the parentheses like that, and then just copy and paste that like 3-4 times. It's just going to print 4 numbers in a row. Now I forgot to specify a starting point and an end point, so this might be a syntax error. I'm not sure. That wasn't my intention. I just noticed it. Didn't actually run. Did I click the wrong thing? Run module? Alrighty. It's yelling at me, missing 2 required positional arguments. So that's my fault. I forgot to fill in the right things here. Don't make this change because I'm going to immediately undo it. But the random function, a whole word random instead of random int, if we look at it, just generates a number between 0 and 1. And that's not what we want, right? I mean, we could convert that, but we'd have to do some multiplication and modulusing and this and that. We'd rather let the computer do all that. So this should be like it was before, randint. And I'm just going to put 1,6, just like a normal cubical die, right? It's got 6 sides. If you're a Dungeons & Dragons player and you like 20-sided dice or 8-sided dice or whatever, you can make it 1,20. I'm just going to make it 1,6, 1,6, 1,6, 1,6. getting real tired of the shell being obscured by the dock. I may move the dock back to the bottom. Anyways, 6124. That's what I rolled. I'm going to run it again. And again. See, each time they're a different sequence. Us humans can't predict what these are, so they look like random numbers. Now notice this syntax that we used to write this. Right? We had to say random.randint. We could make it so that all we have to do is use that randint word, use that function name without using the library name. But to get that to work, I'm going to have to change the import statement. I don't want it to say import random anymore. I'm going to use a different syntax where we bring in that specific function from random import randint. That lets us skip putting our random dot in front of it. Just makes it easier to type. Just like there's a math library, we can get the value of pi. You could do import math. That's one way to get pi. And then when you want to use it, x is equal to math.pi. I forget whether it's lowercase or uppercase. I'll remember very quickly. Looks like it was lowercase. But maybe you don't feel like typing math dot for all your functions, right? So you could change this to say from math import pi. Now we're not going to need pi for this homework, so this is just examples. And I'm going to put in comments that it was math.pi with a plain import math. Hope that makes sense. There's absolutely nothing wrong with just doing import math and using math.pi, or import random and then using random.randint. It just shortens the typing a little bit. But let's set the seed so that it generates the same sequence of numbers every time. Well, why would you want to do that? That's no fun. Well, for testing purposes. What if your program crashes, you know, with a certain sequence of random numbers and you can't figure out where it's going to crash or why? We could set the seed and it would generate a predictable series of numbers each time, and it'd be easier to debug. Find your fault. Not your fault, your program's fault. So I need to import a different function from random. I'm going to add another import, or I could just say import everything with an asterisk. But I'm not going to do that. Just for now, I'm going to leave it with a very specific version. The asterisk means wildcard, which means bring in everything, but sometimes it doesn't quite do it. And then from random, import, and I believe it's set seed. Let me go back to that page I was Googling at and see if that's correct. Oh, it's just seed. It's not set seed. And not seat with a T. Seed. Okay. So, if I set the seed, it'll generate the same number every time. The same sequence of numbers. Not the same number, right? That'd be like always rolling sixes. That'd be tedious. But we can set the seed, for example, to 0. And then every time I run it, those four numbers are going to be the same. The same sequence. I keep saying that they're going to be the same. They're going to be the same sequence. That was a 4413. Go away, PowerPoint. If I run it again, 4413. If I run it again, 4413. And if I change the seed to something else, it generates a different sequence. Normally you don't bother setting a seed. Normally you want your numbers to really look more random, right? Normally you want them to, you know, look like actual dice rolling rather than just the same sequence every time. So I'm going to maybe comment out the call to seed. And what does the seed do? Sets starting point for the random number algorithm. So we could put that in a loop and we could print out, you know, 1,000 numbers in a row. I don't see much reason to do that. But let's write a function that rolls 2 dice, generates 2 random numbers, adds them together, and returns them. So to define a module, you use the DEF keyword. DEF, and I'm just going to call it roll, right? We're rolling dice. Parentheses, in parentheses, colon. And how about D1 for dice 1 equals rand int, parentheses, 1 comma 6, in parentheses. Then I'm going to do the same line, except it's going to say D2 equals rand int, so some judicious copying and pasting might help. Now we might print what our rolls are. Print, parentheses, dice rolled, end quote, comma, D1, comma, D2. And let's get the total. The total is just going to be total equals D1 plus D2. And then the last statement of our module is going to be return total. Now you don't have to be writing modules yet in your code. When I give you homework, you don't have to be doing this, but this is to demonstrate it. You know my style is to show you something before we hit it in the PowerPoint, so by the time you see it in the PowerPoint, it clicks. So total equals D1 plus D2, and then return total. Let me push this up. So me is equal to roll, parentheses, in parentheses, and notice that this is back tabbed all the way against the margin. CPU is equal to roll, parentheses, in parentheses, and we're just going to check to see who wins. But we might want to put a message saying who is rolling. Or let's say you rather than me. I like the fact that each one's got 3 letters. Just kind of looks cool to me. So above that, I'm going to print you are rolling in dot in or period end quote in parentheses. And then I'm going to put another print before the second one. Print computer is rolling period end quote in parentheses. So now we have 2 totals we can compare. If U equals CPU, it was a tie. If U is greater than CPU, U won. If CPU is greater than U, it won. So if U equal CPU colon print parentheses quote, it's a tie. Period. In parentheses. elif, which stands for else if, in other languages they actually use the whole word separated by a space in some many ways. elif U greater than CPU colon print parentheses U1 exclamation mark end quote in parentheses. Else, but there's really only 3 choices. So else, print, parentheses, quote, the computer won, sad face, end quote, in parentheses. And then I'm going to add an end-if comment to end the logic structure. And I think that's enough to run it. Of course, I could have syntax errors or logic errors. So you are rolling, you got a 4 and a 6, the computer is rolling, got a 5 and a 3, we might be able to make this look cooler if this message was on the same line as that one. And by modifying the print statement to do something a little bit more advanced, we could do that. Here's what we're going to do. Where it says you are rolling, sorry, I didn't mean to cover it up like that. After the quote, but before the closing parentheses, see, I'm changing our first print, you are rolling line there. Between the quote and the parentheses, I'm going to put comma, end equals, and then just a pair of quotes. Whether you like double quotes or apostrophes, put 2 of them. And I'm going to do the same thing for the other print statement. This is just to make it look better. End equals double quote, like that. So I changed both of these lines. That's why I'm marking them with comments. Not that you have to put those marks, but that's so that whenever I change things up above, it's harder to spot my changes if your eyes were away because you were busy typing. Run it again. Right? So you are rolling, period. Dice rolled 6 and 3. Computer is rolling, period. Dice rolled. Now, I'd like a space after the period. So I'm going to come back here and change this end equals to not have any space, to have a space. So what does that end equal mean? Well, a print statement automatically goes to the next line. But if you give it an end parameter like that, it says don't go to the next line, print this instead. I could put anything I wanted into it, like the suspense, don't do this, is killing me, right? And then when it runs, we'll see that on the same line as you are rolling, right? Just like that. I don't know, it's kind of funny. Maybe I'll get rid of that though. That was just to prove a point. So I'm going to leave it so that there's a space or 2 spaces inside the double quotes. And I think that they'll space it out so that its output looks really nice. Right? Or if I accidentally click the wrong thing, it shows nothing. There we go. You're rolling, dice rolled. Maybe I should put an equal sign, right? The dice rolled equals 5, 2. And the dice roll, you can keep, fussing with your program to make the output better and better. This will be the last change that I make to that, and then I'm going to let that sit. So in order to put an equal sign in there, I need to go back to my function, my module. And I'm not going to make an end equals, but I'm just going to put my equal sign right there. So it says dice rolled equals. Dice, whoops, and I needed to put that in the quote. That would be a syntax error. Come back over here, and after dice rolled space I said equal. There we go. So I just changed this line as well. That was my third change. All right. So you are rolling. Dice rolled equals 6, 4. Computer is rolling. Dice rolled equals 2, 4. If I wanted to make complete sentences, I could capitalize the D. Not going to bother. You won. I'm going to do that again, make sure that it generates a series of numbers where the computer wins sometimes, right? Okay, there the computer won. Once more. It's a tie. Okay, so it seems to be working, right? Because I've got all 3 results. And if you have 3 branches of logic, that's what you want to do. You want to make sure all 3 branches work, because what if I'd had a syntax error on the it's a tie message, and I never noticed it because I only tested it and got the computer is winning and then you are winning. Now, we could make this more awesome if we wanted to. We could put it in a loop and we keep playing until the user wants to quit, and we could keep track of how many wins we had versus how many ties versus how many the computer had. And if you played long enough, the number of times you won should equal the number of times the computer won, but who knows how many times that would have to happen, right? But if you played 1,000 hands, then if the dice aren't loaded, then, it should be an equal number of times that you rolled versus the computer rolled. All right, so let's close this. Let me walk around, make sure this is good. we could flowchart this, and I'm tempted to do that. The only thing is I don't know how to flowchart an else if. I tend to avoid that just because it looks kind of weird. Flowchart else if. Yeah, I guess that's okay. It's just a little bit than a normal if, right? Why does it look like that? Because if this is true, it's supposed to go all the way to the end, right? But if this is false, it has to do the second check, right? If dice equal, print, it's a tie, and then skip all the rest. Else, if my roll is greater than the computer, print, I win. Go to the bottom. Else, if, and that's just a simple else, right? There's no more if involved. And so we wouldn't have a third branch. We just have a print statement there. I think we could do that. That's not too hard. Does anybody need help getting the code working because you got syntax errors? Is that a yes? All right, let me come back there.
I probably have to bring it along.
No problem. All righty. So if you feel like drawing along, great. It's not going to be an overly long flow chart, but it is going to have a module. And it's going to have some input statements. Actually, I don't see any input statements, only output. And then it's going to have this if, else, if structure. So let's do it. I don't want to spend too long drawing it because I'm in a hurry to actually get to the guessing game. Tell you what, let's make this repeat until we are done, right? So after it prints the computer 1 or U1 or it's a tie, we want to ask the game, or we want to ask the user if they want to play again. So to do that, we need a priming read up at the top. No, we really don't, but we need some kind of play again. And we're just going to set it equal to y. Again is equal to y, and then our while statement is going to be while again equals while, y. Keep repeating. So to get that to work, I need to tab all of this stuff over after that again statement, because this is all going to be in the body of the loop. Boom, like that. So while again equals quote end y, quote y, end quote, colon. And then down here, after the end if, see I just added I'm going to remove these other little red marks because we don't need them anymore. But I did just add these two lines. These are my two new lines. And then I tabbed all this stuff over. And then down here at the bottom, tabbed equal to the rest of the body of the loop. Let's ask them if they want to play again. This time we're not going to use float or int to do any conversion because we just want a letter out of it. So again equals input parentheses quote, do you wish to continue question mark y backslash n space greater than end quote in parentheses. And I certainly did not mean to put two spaces there. I hope you didn't do that just because I did it. And then this is the end of my while. So I'm going to back tab 1 and note that this is the end of my structure with a comment. And remember, the comments are ignored. I could leave them out. So this is the end while. All right, now I think my program, as long as I don't have a syntax error, is going to keep repeating as long as I type in y. But if I ever type in n, or anything else actually, it's going to quit. Now why did I say anything else? Because only time we're going to repeat is while our input is equal to a lowercase y. So even if I type in an uppercase y, it's going to exit. So I'm going to run the module, see if that works. I wanted to put a loop in it just so that it was a more interesting flowchart. Right, the computer one. Do you wish to continue? Well, heck yeah, the computer beat me. I better do it again. Oh man, computer beat me again. Okay, something's wrong. Computer beat me a third time, but my numbers do look random. Looks legit. Oh, 4 times in a row? What are the odds? 5 times? Okay, finally I won. I'm going to cut my losses and run. Right, so stop playing. That was quite a run there. So I just added this statement as well. So those are the 3 things that I just added, and then tabbed everything else. How y'all doing?
Oh, we did.
You're sorry.
No, it's fine.
All right, just continue. Sure, why not? Yeah. Okay. If we were cool, if we wanted to spend all afternoon working on this one, but I'd kind of like to get to the guessing game, then we would add, some counters. And each time one of these events happened, we'd increase the counter. Like we'd increase the number of ties for that one, the number of, our victories for that one, and the number of computer victories for that one. But let's not. Let's do the guessing game instead. And since I don't want to have to play this game before the guessing game starts, I'm going to add our guessing game all the way up at the top. I think I'll delete these print statements. Those don't really do anything anymore. Or I could just highlight them all, and if you're using idle, I know the same thing will work in a version of PyCharm, I just don't know how to do it, and do format comment out region. And then it just adds some of those to it. Now why did I use the menu? Because then I could come back and do uncomment region, and it removes those. But it only works if it's very specifically to the ones that it inserted with those double hashes. Okay. So our game, the computer needs to generate a random number. Oh, I forgot to flowchart this. We may not get to the random number because we're going to flowchart this. Bummer. But let's do it. Need to do it. Hey, I just saw that pro tip, double-click to add text. You were paying attention at one time. Okay, so I need to write my module here. A module starts with an oval just like anything else, but instead of the word start, it has the name of the module in it. And I could even add the DEF keyword if I wanted to. Where's the oval? Pull that over. DEF space roll. Open parentheses, close parentheses. The book would not show adding the word DEF there, but we're special. We can do it if we want. What's the first thing that the computer does? It makes a random number between 1 and 6. So I forgot what I called my variable. D1 and D2. D1 equals random between 1 and 6. And I wouldn't mind if you just typed in RAND parentheses 1 comma 6. But another programmer might not like seeing Python statements in here, because if they did it in C++, it'd be a different syntax. And then D2 is just the same thing. So I'm just going to copy and paste that entire rectangle and then hook them up with a line. That's a process block. All your math goes in process blocks. How did I copy and paste this so fast? Well, you can always just right click and choose copy, or you can just highlight it and hit Control C, Command C. All right, and that's D2 equals random. See if I can draw a little bitty arrow between one and the other. Now I need to add the two lines, the two values together. Total equals D1 plus D2. And if I felt like it, I could put the word set in front of it, but I'm not fond of the word set. So I'm just going to do that. Total equals D1 plus D2. And then a module ends in an oval, just like it starts with an oval, except instead of the word stop, it has the word return in it. And if it's returning a value, like this one is, this one needs to return the total, else the calling code wouldn't be able to use that total. Then we're going to say return total. We want to actually put our return value. So return total. That's our module. That's our roll module. That's our roll function. Now I need to do the main code. And I'm going to skip the import statement, although I could put it in there, I guess, inside a math box. But I'm not going to do it because the way that each language generates random numbers is different. So the main code also needs a start. And then I've forgotten. What's the next? What's after our function call? Is the next line again equals yes? What do I mean by that? Let me find it. After where our function is defined, this is our module. This is the first part of our main code. So start main code. And then at the end of that, I could put a comment down here, stop main code. Just to remind myself that some shapes are going to go there. Okay, so the first line was again equals yes or y, and then while again equals yes. So I'm going to go back and draw that. Again equals quote y end quote. Now I'm almost wanting to put the word set there for some reason, but I'm not going to, just to be consistent. And then it's a while. A while looks just like an if. It's in a diamond. And I've already said this 100 times. I like putting the word while in there, even though the book doesn't show it. While, again, equals, quote, y, end quote. And that's where my code begins to indent, right here. So I'm going to draw an arrow going off to the right. I have a print statement and a roll and another print statement and another roll and then a series of ifs. So jutting off to the right, my print statement, those go in input-output blocks, what it calls data blocks. So print, I am rolling. Or you are rolling. You am rolling. Sound like Tarzan. Here we go. You are rolling. And then a line straight down to actually call our function. Now it looks like math. It looks like it should go in a regular rectangle, but I'm actually going to change the shape of it in a minute. So U equals roll, parentheses in parentheses. That's how we call our function. Now if it's a function call, if it's a module call, it does go in a rectangle, but it goes in a rectangle with bars to indicate that this is actually defined somewhere else in the chart. So I should not have made it a rectangle, so I'm going to right click and choose change shape, and I'm going to change it to the one with bars, which, yeah, how can I tell which one's bars?
It's the third one.
That
on
one.
The top left. Or top right. So third one on the right at the very top.
Okay, cool. Right? So you choose change shape. I should have just drawn it right from the beginning. Oh, and now it's there. Okay, forget it. I'm deleting it. I'm going to drag out the one that says process block. Predefined process, that's the one that I want. However you're going to get a hold of it. All right, and so that's U equals roll, parentheses in parentheses. Now the next two statements are almost the same, right? Except it prints CPU is rolling or computer is rolling, and then it says CPU equals roll. I am real fond of cutting and pasting. So I'm going to copy that shape and paste it. And then I'm going to copy the other module call and paste it. And then I'm going to hook everything up with lines, and I'm going to change the writing inside them. Line there, line there. All right, so print computer is rolling. And then I think that line after that was CPU equals roll. And please don't feel obligated to mess with the sizes like I do, because it starts to mess up the arrows anyways, and I'm not going to zoom in and fix the arrows. Kind of looks lame. All right. Now we have our if block, right? A whole bunch of if statements in a row. If, else if. So the first if was if U equals CPU. That's a diamond. If U equals CPU, and if that's true, it's going to print a message. Print, it's a tie. Or just print tie. Get a little less verbose here. Now, according to that Google page I looked at when I looked it up, this line doesn't come back down and immediately join a connector if it's an else if or an elif. So on the no line underneath it, it's another diamond. And just like my preference is different from the book, I'm going to put else if, or if you feel like putting elif because that's what Python says, either works. Elif, remind me, did we check for our win first or the computer? We checked for our win first because I remember the sad face being the last one. So if U greater than CPU, draw a line out here, that prints you win. And then finally, one last else. And remember, there is no there's no reason to put the word else in here at all. If you felt like it, you could put it on the no keyword there. I'm going to leave it off. I'm going to be textbook about it. Print, quote, computer wins. I'm pretty sure I'm not getting the text right? I'll probably use the word won rather than win or something like that, but the logic is the same, hopefully. Alrighty, here's what the book showed, or that page showed. Having a connector down here, not a node, grab the wrong thing, grab a circle. Having this drop straight down into it, having this one drag over to it like that, and having this one kind of drag over to that too, like that. And then I'm going to put a comment as to what the heck this is. This is an if, elif, else block, or code. Section. There, I like that word, section. Now I kind of wish I'd put it in that shape with the brace, but then I'd have to highlight the whole thing, so I'm not going to do that. Get rid of that. All right. This needs to go back up to the loop now. Now that the connector is done, we're going to draw a line from the connector back up to our while, except I forgot something. What was the last thing after the print computer wins? Before the tab stopped, before we stopped indenting, there was something else after print computer wins.
Do you wish to continue?
Yeah, do I wish to continue? So that was a mistake. I'm going to undo that, and there needs to be an input. I'm at the end of my rope here, but it's okay. If I drag the line down there, it adds a new page for it. And so then, again, equals input, parentheses, do you wish to continue? Question mark, end quote, in parentheses, something like that. And that one can have a line going back up to the while. And then if I'm not mistaken, it doesn't do anything after that. We could have added a print game over, right, down here at the bottom. And then we'd finally have a print statement at the end. I'm going to do that. Before stop main code, I'm going to go back to my code, and unindented, I'm going to put parentheses, okay, game over, end quote, in parentheses, just so that I have something on my flow chart on the no side of that while. Then I'm going to flip back to my flow chart. And the while, the no side, just needs to go to a print statement. This says print game over. And then drop to an oval, which is a stop, because it's the end of main code. It's not the end of a module. If it was the end of a module, I would have put return. All right. I'm sorry I can't get the whole thing on the page. That's about as close as I can come to getting the whole thing on a page without squeezing and squishing things or shrinking it out so far that you might not be able to read it. One more thing that I like to do, and this is just a personal quirk, is to colorize the circle that defines my function. Give it just a subtle shade with the paint bucket up here. Like fill it in with, there used to be brighter colors. I'm going to fill it in with blue. That looks terrible. I'm not grooving on this anymore. Okay, yellow. And then I'm going to make the function calls to that the same color. Why? Because not that it's the most important thing in the world, but just to show, just to make it leap out where I am using my predefined process, my module, my function. I mean, you can color every block a different color if you want. All right, let me wander around and see how y'all are doing. All right. How do you get Google out of full screen mode? I don't know. Guess I'll leave that on the page. How y'all doing?
Is there a way to zoom out?
A couple ways. One is to try holding the Option key and spinning the mouse and see if that does it.
Oh,
Okay,
it is.
yeah.
You also push, hold the space bar and scroll in and out.
Oh, okay.
Since you're on a Mac, you can probably just spin that. Well,
But we can barely, we didn't see that.
never mind.
Till you walked
It's not
away.
really working. Yeah, but you could have done it.
Yeah.
And now I've messed it up.
Yeah,
Sorry.
that's all right, that's right.
All right. Once you're happy with your flow chart, do a save as, or just save, I guess, and call it dice game, or whatever you feel like calling it, lecture, whatever lecture this is, J? Yeah. And then do export as PDF or PNG. If I was going to paste this in a Word document, I would make it a PNG. I'm not, so I'm just going to choose PDF. Click download. Pick my favorite directory to save in. I think I'm going to add the word Lecture J on it just to make it easy to spot. Oh, that's how you do it. All right, could we write a guessing game in the next 20 minutes? That's the question. I don't want to rush through it. We could start it, or we could save the guessing game for Tuesday. Let's do that. Let's just go back into the PowerPoint and lecture a little bit more. That seems like the more prudent thing to do. But I hope that made sense. I should give y'all a program like that to flowchart. I'm not coming up with a good one in my head, so maybe I won't. Let's see if I'm inspired while doing this. All right, so we finished chapter 3. We're going to start chapter 4. The only weird thing that we did about this one that the book hasn't shown us so far is we did if, which looks a little bit different, right? They just jut off to the side and then they eventually hook up back at the end. Really? All right, making decisions. We already know how to do this stuff. We could just close this chapter and say we're done, but we're not gonna. So in this chapter, you will learn about the selection structure and the relational comparison operators, making selection within ranges. Okay, so there's actually some good stuff in here. And the case structure, which our language does not support, so I'll just type it in C++ or whatever, and you can ogle it and nod wisely and then skip it. So the selection structure, that's the diamond. It's the if statement. It's based on a Boolean expression. If U equals CPU, right? That's going to be true or false. If temperature is greater than 32, right? That's true or false. Every computer decision ultimately yields a true or false. Yes or no, or a 1 or a 0. Yes or no, whatever that question is. This is a dual alternative structure because it has 2 outcomes. If it was a single alternative, the yes side would have something, but the no side would just drop straight down because it wasn't doing anything. So that's a single alternative, right? I would have drawn the line just going straight down to indicate that there was nothing else to do. They show the line coming off to the side. And if you remember back in my flow chart, if I hadn't closed it, or maybe I did, maybe I didn't, right? That's how I did my if statements. I didn't make the if statements jut off to the left with a no, because that can make it really chaotic to draw. I just make my no's go straight down and my yeses go over to the right, just because that's how your code looks when you're tabbing it. The code that's in a body is tabbed over to the right. So that's a single alternative. That's a big chart. Memorize it. No, I'm kidding. All right, here we go. Then we have the if, then, else decision. That's one thing or the other. That's a dual alternative outcome. The else side executes only when it's false. The true side executes only when it's true. So if I am hungry, print, let's eat. Else, print, no thanks. Right? Two different actions based on whether the decision was true or false. Using relational comparison operators. Instead of just if x equals 3, you can make it if x is greater than 3, or if x is less than or equal to 3, or if x is not equal to 3. You have several different operators you can choose from. And you've used these like in math school, I mean in grade school, or you know, wherever they teach it now, middle school. Except in every programming language I've ever used, it's actually a double equals to do comparison. Right? If x equals y. If x equals y. Greater than. Or it could be greater than or equal to, right? If x greater than y. Less than. If x is less than y. Now what are the opposites of equal? That's not equal, which looks like this. If x not equal to y. The opposite of greater than is not less than. You might think it is, but it's actually less than or equal to. If x is less than or equal to y. Now why do I say those are opposites? What if x is exactly equal to y?
Well, that's not.
Then is x greater than y true? No, because x is exactly equal to y. And if this just said if x is less than y, is x equal to y? It's still not true. So both of these would have resulted in false. To make one of them the opposite of the other, we had to handle the equals case, right? So if x is greater than y, no, they're the same, so that's not true. So that means that x is less than or equal to y. And the same business down here. The opposite of x less than or equal is, the opposite of less than is greater than equal. Just to handle the case if the two things you're testing are the same. So I'm pretty sure we know what greater than, less than equals. They're saying that this is the not equal to operator. I've never seen that used in a computer language. Every language I've ever used, it's exclamation point, equal. That means not equal. About time to add just a few little notes to our page down here. So you can have greater than, you can have equal, and you can have less than, and then the opposites, go away, is not equal to. Now what did I say I should use instead of a single equal? I just goofed there. If you're going to check to see if x is equal to y, what do? Two equals, right, you use double equals. And then the opposite of greater than is less than or equal to, and the opposite of less than is greater than or equal to. And these are relational operators. And again, they're Boolean operators requiring a valid piece of data on each side. Now in your math classes, it's okay to write this, and it's not okay to write this in a programming language. 3 is less than x is less than 7, right? And that's going to return true if x is greater than 3 and x is. If x is less than 3 and x is greater than 7, right? So if it's between that range. That doesn't work. If we were going to do that, we'd have to write it like this. If x, or if 3 greater than x, and x greater than 7. Or if you felt like rewriting it, you could do the opposite logic, and you could say if x less than or equal to 3, or I'm going to leave it alone. So this is no, and this is yes. That's how you do it in just about every programming language I've ever seen. Why? Because these are these are binary operators, meaning that they have to have valid data on each side. And so if that evaluated a true, I'm going to type this, but I'm going to then undo it. That would be true, not true. And then we would be asking, oh, is true greater than 7? No, that doesn't make any sense. So that's why it has to be worded like this. A valid expression or value on each side of the and. And we're jumping ahead to what and means, but and just means both sides have to be true. If you are hungry and you have money, go out to eat. Right? They both have to be true. I'm not going to go out to eat if I don't have money. And I'm not going to go out to eat if I'm not hungry. And then guess what? There's also or. Or means one or the other is true. If I'm sick or tired, stay home. It's nice when your boss lets you stay home just because you're tired. So, using relational comparison operators, again, there's no such thing as that. It's not equal to. If customer age is greater than 65, then the discount is 10%, else 0. If customer age is less than 65, then the discount is 0, else the discount is 10%. Both of these are the same logic. Notice that to make it the opposite, they just didn't make it greater than 65 and less than 65. One of them had to have the equal in order to handle the case where they were exactly the same. It'd be a real bummer if the program didn't give you the discount when you were 65, if that was the intended logic. All right, common errors. Using the wrong operator. Of course, if the big value is supposed to be greater than the small, or the small value is supposed to be greater than the big, and then you choose the, I don't know if any of y'all ever heard that, but when I was in elementary school, they called it like the alligator mouth. The alligator mouth wants the bigger piece. Okay, anyways. Missing the boundary or limit required for a selection. That would be another common error. Compound conditions. Asking multiple questions before an outcome is determined. That's like AND. You can do AND logic with what are known as nested ifs. What do I mean by that? If hungry, and then tab over, if money, and then tab over, print, let's go eat. And if I was making a proper Python, I'd put colons and stuff like that, right? If money greater than 0, and then hungry greater than 0, right? Then print go, let's eat. That's one way to write it. But if you could write that in 2 lines of code rather than 3, you might like the way this looks better. If hungry greater than 0, and A and D, and by the way, some languages use ampersands to represent and. If hungry greater than 0 and money greater than 0, colon, print, parentheses, let's go eat. End quote, in parentheses. Right? So this is a nested if, and this is and to replace the nested if. Maybe I'll make comments to that effect. This is a nested if, because you can nest any structure inside any other structure, so it's no problem to nest a selection within another selection. And this is using and to replace a nested if. It's just up to you. Why might you want to use the nested rather than the and statement? Well, you could word this in such a way that it said, if hungry is greater than 0, print, I sure am hungry, and then do the money check, right? And then the money check is greater than 0, print, let's go out to eat, else, print, let's stay home, or let's borrow some money from a friend, right? Something like that. And so that's multiple output statements, not just a binary yes, no, right? Print, let's go eat, else stay home. This one might have 3 or 4 different possibilities if we stuck some else's in here, right? So if the logic is more simple than a simple yes or yes, no, then you may need to nest the logic. That's another big flowchart to memorize. Okay, again, I'm kidding. Let's take a look at their flowcharting here. They're declaring all of their variables up at the top. I didn't do that in my code. If I was going to, up here above my function calls, way up here at the top, I could have declared them. Start main code, I could have added a block that said declarations. Again is equal to y, that's a perfectly good declaration. And then u equals 0, and then CPU equals 0. And then I could have added comments as to what those are, right? What is u? What the computer rolls. No, what I roll. What the user rolls. And then the CPU is what the computer rolls. and then again is whether to repeat the game. And if I feel like it, I could take the time to tab everything over, right? So that's a declaration block. If you like the way that looks, if you like having your variables defined up at the top and given some kind of initial value, even if they don't need them, great, go for it. Some languages require that, so maybe I should require you to do it. But you see, when I'm programming, I don't do that. You know, when I was writing this program, I just defined U and CPU right there. Now I'm not going to go back and modify my flow chart to match that, but I could, right? I would just have to go to that again equals Y block, and then I could add a few more definitions to it. Declarations are the only ones that are legal to put multiple statements in the same block. So I could come up here and say again equals Y, roll equals 0, and, or you know, U equals 0 and CPU equals 0. I could put them all there in the same block. Not gonna. Back to the, after the declarations, they do some so-called housekeeping. The housekeeping is a separate module, a separate function. So that's why it was called in a rectangle with a bar. Here's our housekeeping function. Instead of having start and stop, it defines a function. They left the DEF keyword off, that's okay. And then it has a return, just like we did. Here's another function called finish, another module called finish. And they call that somewhere else in their code. Wherever. Right there, finish. And then they have an if statement, and they have a nested if statement, and then they print some output and they return. So, nesting and decisions for efficiency. When nesting decisions, either selection can come first, but efficiency can be improved. Wait, where'd my notes go? What if this was true more often than this? If I'm hungry a lot, but I only have money a little bit at a time. If I'm hungry a lot, it has to do both of these checks in order to determine whether it's going to print that message. But if the reverse is true, I'm wealthy, I've got lots of money, but I'm not hungry very often, then there's no reason to check hungry first. No, that's opposite. You want to put the one that's false first most often, so you can rule out the second one. That just helps the computer run more quickly, because if it can only do one check rather than two, the program runs more quickly. So when you're using AND logic, put the first condition that is least likely to happen first. Or is exactly the opposite, because if this was some kind of an or, if hungry or money, well, if hungry was true, then it doesn't even need to check money if it's an or, right? So for or, you would put the case that is most often true first. I hope that kind of makes sense. Now, Python isn't a super fast language, so efficiency is not really but you aren't going to always be using Python. So, and means both sides must be true, or means one side or the other, or both, must be true. For and, put the case that is least often true first for efficiency. Because that way it can skip the second check, right? If I'm not hungry very often, it doesn't even ever need to check money. If I'm never hungry, it never checks money, and that's great. For or, put the case that is most often true. First, for efficiency. Alrighty, we need to wrap things up. I can't say that I've hit a good point where I feel comfy assigning homework based on this lecture. Let me go look, see if we have a pre-made assignment.